Okay, so hello everybody. My name is Anatoly, and today I'm going to take you all on a journey, but not just some journey. It's going to be a journey full of mysteries, full of state. It's going to be a very stateful journey into the Clojure universe, and I'll show you a way which works very well for me, and I hope for others as well, on how I manage this state within the Clojure universe. And then we're going to do this with this library that's called Mount. So before I go any further, I want to thank a company I work for, which is Chariot Solutions. We're a small consultancy out of Philadelphia, and of course the software GR and JC for getting me here, keeping me fed, and giving me a place to spend the night, which is always good. Not that I don't have space to spend the night anywhere else, but I don't in Grand Rapids, and now I do. So that's that. These are the things, and I'm really thankful. So let me start from these two different worlds that you may slowly recognize as I'm talking about them. So the world on your left is the world of rules, right? This is where everything is strict, where the world where you rely on things. Nothing can break there. It has to be up all the time. No, 99.9, 100% of the time. It's impossible, but that's the requirement, right? So it's something that you can probably resonate with, and this is the world of production, right? The world on your right would be the world of development, right? This is the world where I want to push the limits. I want to break the rules. I want to create things. I want to do unimaginary things. I want to break things, create them, break them again, try it out. So that's what makes me create more robust things, right? If I do, if I follow the rules and do things as by the book, usually I don't go beyond the book, right? And the idea is to go beyond the book and to create something new. And that's the world of development, right? When I create something in the development world, I usually package it up, and my friendly whale kind of ships it into the world of production, right? Your deployment may vary. You can send a jar, see copy, anything, but this is usually what gets done. You created something out of very messy loop cycles and cycles and cycles, and then package it up and make it robust and reliable and send it to production. We Clojure developers and Lisp developers in general, we have something. One of the superpowers we have is that it's called Repple, and that Repple can be a network Repple. What it means, we can actually deploy our application with something listening, something constantly ready for us to log into and change things while it's running, which is pretty cool. And I was going to reiterate this to world with you in text, so it's not just a bunch of mumbo jumbo. So again, this is the world of production. The red, don't touch it. It needs to be reliable, secure as possible. It needs to react to business needs. And the world on the right is development world, where I need it to be as open as possible. It needs to react to my needs. I may not care about the business at the moment. I'm learning this little thing. Maybe I'll use it later, maybe not. And I need to explore things, hack on things, and define things, redefine things, and so forth. So we're going to focus right now on the problems that impact the development flow when you develop applications. And this is going to be a Clojure specific, right? Somewhat Java specific, somewhat Genuine specific, but this is going to be mostly Clojure specific. And again, stop me at any point, ask any questions if it doesn't make any sense, or if it doesn't make a little sense. So first thing is, I mentioned the REPL, right? REPL is this interactive environment where REPL stands for read, evaluate, print, and loop, right? So what REPL does, you print something in, it reads it in, evaluates it, prints it back to you, the result, right? And this loops back. And then the loop continues. You print something in, it evaluates it, shows you what it is, and then loops back. And that's what makes it interactive. You enter something in, and it gives you the result. And you can do it in little fragments of code, right? That's what Lisp is usually great about, is you have these little fragments of code that you send all over the place, and they just get evaluated, and the result is shown. But the problem is that if you work on the application, the REPL launch time, and these numbers are from 2014, but REPL launch time actually impacts the way you develop, because sometimes you add a new dependency, sometimes you add a new namespace or a new class, sometimes you add a new function, sometimes you change something, and you wouldn't want to restart the REPL every time as you work in it. So the way you usually work in Clojure and I'll show you these numbers. So the way you usually work with Clojure, you start your REPL sucks in your class path of your application, compiles, line again or boot will compile things, and then in the REPL, you can actually play with your application as you were inside the editor. It's almost like if you've never done this, it's almost like if you debug in an application, for example, a Java application, C# application, you put a breakpoint, it gets to the breakpoint, and then you start, playing with variables in the middle of your application. So REPL gives you that and more. It gives you kind of not time-bound environment to work with your application. So you have a person object, you have an address, you have a function that gets the address of the person. In REPL, you can just play with person and address and that function. But the problem is that REPL usually is started, it takes some time to start it. For example, for a brand new application, and we're looking at line again on boot here because that's what's useful. They suck in your class path, and you can work with your application. It takes about 5 or 6 seconds just for the brand new application, right? As you add more things, more dependencies, and more classes, that time only increases, right? So sometimes it can take 30 seconds or 40 seconds to start your REPL. So you definitely don't want to restart REPL every time you change something, right? Well, maybe you do, but I don't, right? So the idea is to kind of keep yourself in the REPL as much as possible, because if you do restart it, it kind of impacts your development flow. You thought of something, now you're restarting the REPL, you already destructed, you forgot about it, and it's kind of that's an impact. In ClojureScript, and ClojureScript is a Clojure on JavaScript. Clojure code compiles into JavaScript and runs in the browser. So in ClojureScript, of course, it's the story is different. There are REPLs that start immediately or almost immediately, and the problem is here is that they don't suck in your Java class path. It's a front end, and this particular problem does not apply there, right? Because these REPLs start pretty quickly. So that was the first problem. The second problem is namespace recompilation. So namespace in Clojure is kind of like a module, if you will, in Python, or even you can go as far and say class in Java. But I just don't want you to go that far. But let's say you have a namespace and you have certain function in the namespace and certain states in the namespace. And say we have a database connection as one of these variables, or one of these functions. So database connection is, in this case, is a map. So the braces in Clojure create a map, right? So it's a map with the 2 key value pairs: status disconnected, status is a key, disconnected is a value, and con is a key, connection object is a value. So the way we think about function application in Clojure, we have a value in one time. Right, we apply a function to this value, and in a different time we get a different value. Right, so 5 seconds ago I was disconnected, now I'm connected because I applied this connect function. And that's fine. I mean, if you do that, let's say you go to the REPL or you work in your code and you say, okay, now connect to the database. So you get this second value, right, where your database is connected. But now what happens if you change something within your editor, whether it's IntelliJ or some other VI or Emacs? You change something within the class, and now the class is recompiled. As the class gets recompiled, the initial reference to that database connection is wiped, right? So you still have this connected object in JVM that you do not have reference anymore to. So you cannot disconnect it, you cannot do anything. So it becomes dormant and becomes kind of on your way. So that's a problem. It's kind of, it does impact the development flow. And I just want to stop here for a little while because I see some people are a little bit confused. So I just want you to ask me questions, and I'll go through it a little bit in more details. Who is the brave one? I know you guys have questions. Come on. Do you understand what's happening here? Okay. Then I guess I was wrong. Okay, so the third problem is the mutability of external resources, right? So, for example, your database connections close at runtime, right? Your database is used by other applications, right? So, or not necessarily database. A service that you use is used by other applications and could potentially mutate the state of that service or what the service does. And that all happens at runtime. The socket connection close and timeout, thread pool workers die, files gets moved. And so this is the problem of external resources, that we don't have any control, right? So we don't have a control of what's happening. Like that car goes and passes on the street. I have little of control. That can stop, it can go, it can, unfortunately go into the building. We don't want that, but I have little of control. So these are external resources of my application that I have to deal with. And it gets a little out of control. And it does impact development flow, right? So now these are some problems, right? So now let me present you some ideas on how to tackle those problems. I'm not going to necessarily apply these ideas to the problems right away. I'm just going to give you a couple of ideas. So first, as we just talked about external resources, the first idea comes from clean architecture, and it's coined by Uncle Bob. So it talks about keeping the external resources on the edges of your application. So for example, if you have your business logic, you have your controllers and use cases and everything, you have it within the application, inside the application. So your external resources, for example, a connection to a database, or a connection to a file, or devices, or your browser, or whatever, UI and external interfaces, they're usually kept outside, right, on the edges of the application. This is just one of the approaches how you architect your system. This is not say that this is not how this is the only way and you shouldn't do it any other way. This is just a way to do it, and I found that this way works. And sometimes it's called onion architecture because you can see it as layers of onions. And you always should reject that seduction to use this external resources within your business logic. So don't let this blue circle inside your application. So that's one of the ideas. Another idea would be you have this states, right? So you have, for example, the database connection example that we saw. It's a state. You created a database connection. It's connected. Now it's a state. So why not add a life cycle to it, right? Say the state would, for example, have a beginning and it will have an end. Something that can start that state or that resource, or something that can stop that state and resource. So just another idea. And in general, I prefer my code as clay. So I prefer to, and again, we're talking about development, right? I prefer to break things, create things, break them again, create new things. And as many times as I repeat the process, I tend to see that what I build addresses a lot more problems than the initial things that I start building, and becomes more robust. And I'd like to show you how I do that with Mount. Before we go any further, any questions? Any confusions? All good? Okay. So first, let's see what are the examples of state. When I say state, what do I really mean, right? The easiest thing to understand when you're talking about state, it's to imagine all those uncontrollable external systems and resources that you have. So here you definitely can recognize some of things on this picture. So you have, what do you have? You have Redis, Hadoop, Datomic, AWS, Zookeeper, Kafka, and probably a lot more that you can throw in this picture. So this each thing here represents a state, right? And in Mount, you tell it for what it is. You just don't say, this is Kafka, let's do something special here. This is, Hadoop, let's do something special here. This is database, let's do something special here. You just say, this is a state. So let's define a state. And there's this macro that's called def state, and you just use it to define a state. That's pretty much it. And for guys who never used Lisp, this is exactly the same thing as you would say, def state space parenthesis state parenthesis. Just one parenthesis is in the very beginning. That's how Lisp works. But it really doesn't make it different. So now let's add cycle to this state, right? So now the full API would look something like this. So you define a state. For example, you define a database connection, and you give it a start function, and you give it a stop function. So this is, in nutshell, this is 99% of APIs to Mount. This is how you use Mount, and basically you have a state, you define a state, give it a name. So state here is just a name, and fn are arbitrary functions. It could be values as well. They don't have to be functions. And I'll show you some examples, of course. So this is all you have to deal with. Most of the things you have to deal with when you deal with state and Clojure using Mount library. So one nice property that it has, so this is an example of such a state. For example, a stop function is optional, so you don't have, sometimes you do need to provide, sometimes you don't. So this is an example of how you define a config, right? So say you have a file with your properties or configurations, and it lives in that file path. So you have some function that's called load config. It loads config and does whatever it needs to do with it, maybe parses it, maybe puts it in the map, whatever you want to do with it. And when this state is started, what you read here is when this state is started, a config variable, a config reference will point to this map that you just sucked in from the file. That's how you read it. But the nice thing here is that since def state is a macro, the way macros work, they are what we call it expanded at compile time, right? So as a Clojure compiler goes and tries to compile the code, it expands macros before, at the compilation time. So mount has an ability to hook into the Clojure compiler and say, okay, so you are config, right? So I'm going to name you config, and what else do I see that needs a config? Say we have a database connection that actually connects and has config as a parameter to the connect method, to the connect function, right? So Clojure compiler will know at this point that I cannot create DB before I create config, right? Clojure has a single pass compiler, so it's going to go back to the config if it didn't yet compile it, compile the config, create the config, and then say, okay, now I can create this DB, and now I can pass the config in. One of the nice property that it gives to mount says, okay, I hear what you're saying. So I'll say config is order number 1, say, and database order number 2, which gives mount an ability to start it in order later and to stop it in reverse order, right? So mount just observes the compiler, records the order, and that's how it knows how to start things and how to stop things in order. And I'll show you that in a second. Another nice thing that it provides, you can just for you guys who didn't use Clojure, this is just an import statement. Require is just you require something in the one namespace that lives in some other namespace or a library. So you can simply require, let's say, that app config. I don't have a mouse here, but that app conf thing here is another namespace, and we basically here we're reaching out to that namespace and we import that reference that's called config, right? And then we can use it in our namespace. Let's say they live in different namespaces or different modules, right? But because def state inherently creates a var, in Clojure speak, a managed var, not just a var. You can actually reference it in different across namespaces. So you don't lose anything. You work with it as you would work with a different function from different library, from different namespace, which is a nice property if you know the alternative. So this is how it would work, right? You call mount start, and you can see that that mount starts config first and database connection right after it, and says and gives you I just started config and connection, and you can see that they come from different namespaces. So this comes from this namespace app.conf, and this comes from app.db namespace. So that's how you read it. And mount start is something that you call. So once you define all your states, it's just your source code. Mount start, usually mount start is you would put it in your main method, or whenever, or in Repple when you want to start your application. So you call mount start and it just starts all the sources, all the states that you just defined. And same thing happened with mount stop, right? And you can see that it stopped only the DB connection. It didn't stop config, because in config we didn't have that stop method, stop function defined. Yep.
Are they single instances each time, or are they separate instances or single instances every time you reference config?
So the question is, are they single instances or different instances each time you reference config? When you mean between the start and stop, or just in general when you
start? Wherever I use config, is that configured for that specific thing, or is it
so that's a config. It's app.conf/config. So it's a one config for if you import it from this namespace, for example. So it has a namespace, which is how you kind of can differentiate between this config and the other config, if you need the other config. But yes, this is a single reference that you use everywhere in the namespace from this namespace, if that's the question. Does that make sense?
Yeah.
Okay, cool. And I'll show you a little more examples. It's going to become a little clearer. Okay, so namespace recompilation. As I mentioned before, we connect to a database, then we connect it to a database, then we recompile the namespace, and we have this dormant connection in JVM we have no reference to anymore, right? So the way mount goes about it, if you remember, def state is a macro, expands at compilation time. So when we compile the namespace or recompile the namespace, well, mount just knows about it because it's a macro, right? So it can hook into it. This is just an example of me, in VI, I just recompiled it, and the mount picked up on it. It stopped the connection and started again, right? So it restarts on every recompile if you need it to, right? That's what happens. That's what happens on default, right? So by default, it just gonna restart the server in this case if you recompile the namespace where the server lives in. You can opt out of that. You can say, on reload, when you reload the namespace, just stop the server. Don't restart it. Or just do nothing. And an example of do nothing is when you work, for example, you work in Repple and you have and you start a web server, right? Say Jetty or even Netty or Tomcat or whatever. It binds to a port, right? Sometimes when you restart it, you won't be able to restart right away because it doesn't reuse the address. So it's going to give you I cannot restart because I already bound to this port. So maybe you don't want to restart server all the time as you restart new app. So you can say, whenever you restart your app or whenever you recompile your app, don't restart the server. Don't do anything to the server. It's just an option to have. By default, everything is going to be restarted as things get reloaded. We good so far? Sure.
Maybe I missed it, but how do you determine what order mount starts things?
Okay. So let me go back here. So we use this def state macro, right? And here, def state is a macro. That means that it expands at compile time, right? So whenever Clojure compiler needs to compile it, it'll expand this macro, right? Which means whatever I, as an author of this macro, will put in there will execute, right? So when Clojure compiler let's say Clojure compiler sees this first. Right, just so happened that this is the first namespace. These are different namespaces. Let's say that the Clojure compiler sees the database first. And it says, okay, can I compile this? I can compile this, I cannot compile this, I don't know what it says. Do I have a reference anywhere in other namespaces that I haven't yet compiled? Oh, yes, I do have it. It's here, right? So this macro did not finish yet, so it couldn't do this, right? So it goes here, it creates this config, right? And mount says, okay, order 0. Then it comes back here, creates this, mount says, oh, okay, order 1, and so forth. So it goes and travels, because mount actually owns this macro. And within that macro, every time you can compile, every time you're able to compile it, you can record the order.
So the order that those expand is the order that dictates what order they started? Later
on, yes. Okay. They don't start, they're not going to start right away. But since compiler will not compile, basically it's your dependency injection, but done by compiler, okay. Right? So it's not done by by your Spring XML or something or manually. It's done by compiler. Mount just watches and says, okay, I got you. It's 1. Okay, it's 2. Yep. And then it creates this the order vector, if you will.
Thank you.
Sure. Okay. So we got that. Okay, yes, we reload this. And again, most of the things you probably don't even need to use most of the time. It just the defaults are usually good. It's just some options you have there. So if the namespace gets recompiled, you can opt out from restart. You can say just stop, or you can do restart. So this is just an example of an application organization talking about keeping your external resources on edges of application, right? So in this example, and I'll have a couple more examples. With time, it's going to get clearer and clearer. I know that right now it's a little strange, but so this particular less exciting application, but I just used to work in high frequency trading for some time, so I can get it out of my head. So one of the applications that I created, it's this very simple reference application. The idea is that you have this this financial exchange, right? We call it the Neo Exchange, and because it's the V1, and you have brokers that send orders, and then you have market makers that send quotes. The way it usually works is brokers are for normal people like us, right? We go and buy IBM for $160, and the broker says, okay, let me get your order, let me prepare it, let me send it to to the exchange. And market makers are no joke. Market makers are those big, huge companies that send liquidity, right? They send billions a day, right? Or millions a day, depends how big the market maker is. So they're always faster than brokers. Brokers are just not moving from their perspective. And market makers, by the way, call us food. That's the real term that they use inside, because they just send a bunch of things and they try to see who's going to match. This is going to match to Jesse, is going to match to me, who is going to eat today, right? But besides the point, so that the idea is that you have this matching engine, and that's kind of the oversimplification of how the real financial exchange works. There's a matching engine, and if my order, I'm going to buy IBM for $156, matched one of the quotes of market, I'm going to sell IBM for 155, so I definitely can buy it for 156. It's going to actually match it and make it 155 because it needs to go in my benefit. So if the matching engine actually matches the two quotes, it's going to create, and it's going to look at the order book once you get the quote. If it matches, it creates a trade, right? And the trade is created, so it means I just bought IBM, and later on in the day, it's going to go to clearinghouse. If the clearinghouse says yes, next day you might get your IBM share if everything went fine. So the business model here is actually irrelevant. I just went over it for the sake of it. But this is how, in this case, this is how I chose to architect, to design the application. So here you can see that I have. This would be my server, my web server. This would be my database connection. This would be my config, and this would be my network REPL. So all these are resources. All these are states. This is not a real resource. It could be if it's a file, for example. But these are states, and they kind of kept outside. And this is the business, and the business is kept inside, and it can reference states if it needs to, but the states live by themselves and they live outside. I can swap in, swap out all those different states. So the application looks something like this. So this is the business, right? You can look on all the orders for Google. It's going to give you all orders for Google. So the book or orders, I forgot, will reach out to database and will read the orders from the database. But again, the database does not live within orders. It lives outside, and you can switch it. Oops, sorry. You can switch it for something else. This is just an example, and this is. I'll post the link. This is available. I have all my reference applications are available. So this is not a lot of code at all. So you can look at it. This is just an example of how you structure an application with keeping external resources outside. So you're keeping them separate and you're keeping them outside of your application. Just a oversimplification. So another example that I want to show you is how to, since you asked whether that config is the only thing, right? Or you can have many configs. Sometimes when you test, for example, maybe you want a different config, or maybe you want a different database, right? So the way you do it mount, you just swap. As you start mount, there's an ability to swap that config with something else. With the value, with a different config, you can say start with or swap, and you say this config, that's going to be a map. Key is what you want to swap, and value is what you want to swap it with. And I'll show you that in a sec. So this application is pretty trivial. It has a web server that gets an HTTP request. It has a config that has some port and whatever, and it has this function send SMS. Right. So the send SMS function uses this Twilio library, which is a real library that actually can send an SMS to your phone. I mean, it's not a rocket science, but it's pretty handy to play with. So basically, this issues out the HTTP request to Twilio itself, and Twilio sends an SMS. This is my phone with an SMS that says something. I can see what it says. This is basically how it's done underneath. So we have this application. You have this send SMS will be a state, and notice that in this case, send SMS. The reason it's a state is because we pass from the config. We pass, seed and auth token. That's something that Twilio library needs. And then we return back a function, right? We return back a function that takes from, to, and body, from my phone to your phone, and this is the message, right? And this function closes over this state and gets returned as a send SMS state, right? So now this function, now the only thing you need to pass to this function is from, to, and body, from, to, and body. And every time it's going to send an SMS, it closes over this state, right? It created the Twilio thing, the Twilio client that is able to send the message. And now it's stateful, that's why it's a state, right? It closed over that state, and it returned here. But this is now a function, so you can actually use it as a function. So say you want to test this, right? Say you want to test this function, like this particular function. If you want to test it with, like, let's say, 1,000 of messages or 1,000 of requests, it wouldn't be cool to send messages to thousands of people, right? They wouldn't like it, especially if it's a business. They would think you're annoying, I think. So instead, you can do something like this. You can actually create a send SMS function in this case, which is going to be just a value. It's a function that takes something and puts it on the channel, right? So what this means, think about this. It's called core async enclosure, but think about this as a queue, right? So it takes message and puts it on the queue, and later on you can check that queue and see whether you got this message or not, right? So basically, when you start mount, you say, hey, I know you have this send SMS state, but instead of whatever it says right there in the start function, don't use it. Use this value, which is this function, right? So now, when the whole application is started, whenever somebody calls, send SMS from to message, it's actually going to take the message and put it in this queue. And then later you can test and see that the message got to the queue and just verify the message. Then at the end of the test, this is an example of a test. So at the end of the test, you just stop the thing. Yeah, again, so start with takes a map, because you can't replace many states. Let's say you have 10 states. You can say start with, these 3 different states now are this, right? So you can kind of simulate the application by giving it different states at start. Does it make sense? Yeah.
And so this new send SMS function that you're using for testing purposes, do you define that in the Repple before you call out start, or is that a separate config file or something along those lines?
Okay, so the question was whether I define this function in the REPL or that's a separate function that lives somewhere right in the namespace. So this function actually lives here. This is exactly where it lives. So imagine like this would be a test for blah blah. And here in the let binding, basically this defines as this scope. In this test, I actually define this function here. So I can do either. I can define it in REPL. I can reference a different namespace from a different function. I can actually swap states as well. There's also start with states. You can actually swap 2 different states. If you have in test, you can def state test something, and you can actually swap those states. If it gets a little bit too complex to mimic, to mock, to stop, you can actually define a state and just swap the states together. And I don't know if you guys can see it on the back, but all these things like start with and swap, accept with args, all these things are composable. So you can say, for example, we have an application. So let's say I have 15 different states. In this particular use case, I'd like to only start this 5 states, right? And I also want to give them runtime arguments, right? Like you would give it like a system proper arguments. And oh, by the way, and I also don't want to start C and D. I know it's a little silly because I would not just include them here, but this is just to illustrate that you can do accept. So start only this with args, accept this, and swap states, something that I mentioned before. Swap A with test A, right, in this case. And or swap, bus E with this dynamic URI, right? And then start. So basically all this like compose, and just the final number of states with all the substitution gets passed to mount start, and then just starts. Right. Usually you end up using just this part, but just in case if it gives you some flexibility if you need to. In testing, usually in testing it's actually pretty flexible and pretty useful. Okay, I know this is a little more than
Kind of getting back to my earlier question.
Sure.
Start only happened once. Does that happen in 1,000 or say it's
Oh no, start happens when you call start. So when you
explicitly call start?
yes.
Okay.
Whenever you want, yes. You can go to the Repple and call start. Maybe it's a good segue.
In one of the applications, you throw in your main method. So like when you launch your application, yeah. Okay.
Yeah, this is, if you're familiar with Java and Spring, when you create an application context, you have a new class path, XML. Sorry, application context creates all the application context. Usually it's put in the main method. In web applications, it could be put on the init call to the web server when web server starts. In ClojureScript, you can put it anywhere in JavaScript when you on the click of a button or something. It's up to you. So it's on demand, and you can start. You can start if you say mount start. For example, here I have. Can you see it on the back?
Yep.
Okay, maybe let me make it a little bit bigger. All right, so let's see what I have here. Okay, so in this case, I'm starting something, right? And in fact, I'm starting that Neo Exchange application that I showed you, the first example. So you can see it started config, database connection. Noisy app is, first I called it New York Stock Exchange, but it doesn't matter. That's in past now. And Repple. So these are the 4 states that started, right? So if you call mount start again, it's just not going to start anything because all your 4 states are started. I could have done this. I could have say, let me stop it, and I could have say, start just this. It doesn't matter if it's a string or not. It can take this. Well, connection no, because I need config, I think. Yeah, maybe. Okay, config was not stopped, so it still should be up. Right, so the config, I need to start config too. Let me start. Right, so let me just do it again. So right now, I need to stop it. So right now I just started 2 out of 4, right? So because at this particular case, in this instance, I just need 2. So I just said mount start this, and I do know that I need config, because when you start to start in different states, you do need to know that, for example, database configuration is dependent on the config, right? Mount knows the order, but the actual dependency graph it wouldn't know. So that's the difference, for example, from things like Spring. In Java, it would create a real graph of real dependencies, and you can start this one state. It's going to walk the tree and say, okay, I need to start this, and this in order to start this. Mount doesn't do the Mount trusts you to do that. And I opt out of it by consciously, because sometimes I do need to start something breaking. I like to break things, as I mentioned before. So this would not work if I let me stop it. As you saw before, for example, well, I'll just reset the thing. Let's start the database. Right. Now it's already started. Yeah, this is just how I wrote it. It doesn't. It's actually, usually you would see things as I cannot start the state because some other state is not started. This is just the way I implemented it, that's why you don't see it. But due to, this is not good, of course. Not very clear what's going on. But usually you would start, you would see things that, let me try to reset it again. Okay, stop, start, say, and Repple. I will just run Repple. Okay, yeah, I'm getting ahead of myself here, but just trust me for now. I don't have that example, but it would say that. You had a question?
I might just have a dumb Clojure question. Those things you're passing to mount start.
Yeah.
Are those like readers for like importing something?
So, so this would be you're asking about this pound sign things, right? Yeah. So this would be a var in this case. So let's say, right, I mean, it doesn't see it. Oh, it's not. I mistyped it, sorry. Yeah, that's why it didn't work. Usually when there's a live demo, that's usually what happens. Yeah, that's what I meant to do. Right, cool. I mean, I didn't start config, that's why I didn't start it. I'm trying to reproduce that error. But to answer your question, this is a var, right? So, and the pound sign is there's something that's called a Clojure reader, and this pound sign, when it sees a pound sign, it actually goes to a default things that reader can read, and it sees if this particular thing, in this case a single quote, is mapped to a certain thing, is mapped to a function or a type, right? So you can this way you can, for example, define, you define a map. This is a map, right? This would be a map in Clojure, right? And however, this would be a set, right? So it just, if it sees hash and then brace, that means it's a set. It's kind of that just gives a Clojure reader a way to see things. But if you want to refer to a var within the Clojure app by its full name, you usually say pound and namespace. You usually don't refer to var like that. You can use a string here as well. Stop this, start this. Let me do. Hold on, let me. I apologize, I'm all over the place. I'm just trying to mimic that error, which I can't get to. Right, you can see that these are strings, for example, but they don't have to be. They can be vars as well. So what we need is we need to start this and start this. Right. Yep.
So that's essentially just like a named variable, and Mount's using that to look it up, or does that resolve back into a value when you call?
So no, Mount just records it. When you say, so it's this is how it's recorded in Mount inside of Mount. So when compiler goes around the application and compiles things, Mount collects those def states that it finds, right? And then it needs to reference them somehow. You can have config, as you asked. You can config in one namespace and config in the other namespace. So it needs to differentiate between the two, right? So that's why hence the namespace prefix, right? And this is just how they're represented in Clojure. Usually you would not refer to them like this. Usually in the code you would do something like this. You would say require. Well, in the code you'll do :require, but in Repple you'll do require app config, refer app conf, right? Refer config. Right? So now you can see the config, right? So this is how you would just work with config within your code, but it just so happens, and we can probably make it prettier. Yeah. It's a little too big. Yeah, but this is the config for this particular application, which is just a map. Okay, so let me go back and I'll jump in later when. How are we doing on time? Are we good? Yeah. Okay. So you can compose, all the ways you can start Mount before the call to Mount start. And an interesting thing you can do is you can actually, with Mount, you can start and stop parts of an application, as I just showed you. Like I started 2 states out of 4 states. But the more interesting example, which I'll show you right now, is when, for example, we have a Hubble telescope, right? And a Hubble telescope, it's strange that it has this little dots here. Makes it even more mysterious. It should be just the sky and the stars and everything, but it gives it this little green, mysterious grid. Okay, so the telescope takes pictures, right, of nebulas, of galaxies and all that. So say we need to change a camera in a telescope. Like the choices are: do we bring the whole telescope offline, quote unquote, bring the whole application offline to change something, or can we actually log in there using the network REPL that I mentioned in the very beginning, and just change this one thing? We'll just swap a camera. The telescope still reports back to us. It still uses other cameras if it has any, still uses other components of itself, but we can just change the camera. And Mount allows you to do that. You can do it in your Repple. You can log into the network Repple of a running application in production and development in QA and do these things with Mount. And there's a link to this application, but I'm just going to show you how it's. Yeah, this GIF takes a lot of memory, so it takes time to. So this is a Hubble. So let me. I don't know if you guys see that. Let me boot it up. And I have console running. Do you guys know what console is? So have you heard of Zookeeper maybe? So it's Zookeeper console etcd is those products that keep your configuration in one place and share the configurations with other applications, right? They have in console it has a built-in DNS server. It has a service discovery, so you can do a lot of things with it. So in this case, I have a console running which looks something like this. Let me make it bigger. Okay. Right. So I started the application. So the application should have I created the Hubble. Some data about the Hubble, and this data is then used within the Hubble telescope to start. So when the Hubble telescope starts, in this case, and you may be able to see. Well, let's move this over. So you may be able to see this. That it basically does this puts to the console, right? It does this 4 puts. So it puts some target, the mission target, the camera mode, the store URL, its internal store, and there's some server port, some values in console. And then after that happens, the Hubble starts, reads the values from console, and applies it to itself and starts working, right? So this way you can actually start many other different Hubbles that will read this information and start with the same configuration. So let's just look at the Hubble itself. So we are going to go to localhost. Wow, this is not what I was. That's very strange. Might have do something with the resolution, but maybe try. Huh?
Is it just zoomed in really far?
Oh, you're right. Okay, so I'll just bring it here. Can you guys see this on the back? I know that you probably won't be able to see the space log, but basically. The space log will say what's happening to Hubble. Right now, the Hubble just shows a nebula. It uses this camera and this store. So for example, let's change the store, because historically Hubble telescope used to work on tape, right? But let's be adults here and change it down. That's why it didn't work. Okay. Well, it says tape. I'm going to put SSD here and make it smaller again, and do update. Right, and you can see that it just changed the store to SSD, and here it says that it changed store to SSD in the space log. You're going to have to believe me on that if you don't see it. But what really happened is we have a running application, and we went and you can see in Mount logs, right, in Hubble logs, that we took the store, right. This is we called mount stop store in this case, right, in a way, and then we restarted the config, but that's implementation detail, and then we restarted the store. So the whole Hubble was online, doing everything it needs to do, and we just performed a store upgrade on the live Hubble telescope. The usual stuff we do at work. So now this was okay, but not as flashy. So now first of all, now let's see if we can, travel to some other nebula, maybe a more beautiful one. So we're going to Hubble. I'm going to mission target, and let's say I want to go to Horsehead Nebula. Right, so the Hubble retargets itself to Horsehead Nebula, and here's the nebula. Again, this is on the running application, right? So the camera though is okay. I mean, it could be better, right? it's missing something. What is it missing, you think? That's right, it's missing color. Because it's a mono camera, right? So we got a little more funding from government and we got a colorful camera. So let's update that, right? Much better. So you can see the camera was restarted. If you look at the, again, look at the mount logs, you can see that this is not mount logs, this is Hubble logs. It just, this particular message comes from mount. So you boom, you restarted just the camera, and so forth. I mean, you can, you get the point. So basically the idea here is you incrementally restarting parts of an application, which is really handy. I was going to mission. Yeah, maybe butterfly. Is it 2 T's or 1 T? Huh, is it 2 T's? Well, that doesn't matter. So basically it does, you know, and all things are kept in log and everything, but log is not restarted. It's space log, but it's not restarted. The interesting bits here are the components that we're actually restarting at runtime, which is very important for, you know, for your state management library, I think, to be able to do. Okay, this usually takes some time to switch because this GIF takes some time. All right, I think that's fine. So some other things that I mentioned that and I didn't mention before. So you can swap alternate implementation as we saw in test, right? You can swap send SMS with a function. You can, the start and stop order are preserved by mount. The start and stop parts of an application, we just saw how we can flip the camera. And storage, for example, start application without certain states. We didn't see that example, but basically you can say start everything, but without these 2 states, right? Or except in this case. Okay, so this is some treasure box. And now I just want to switch, before I go to ClojureScript, which is a Clojure compiled to JavaScript and run on the browser. Do you guys have any questions? Sure.
Go ahead.
So I'm a little confused how the specifics of like restart listener and the watchers work in Hubble.
Ah, okay.
Yeah, so that's just not something I've seen before.
It's because I just added it 2 days ago, or 3 days ago. Yeah, so the question is about the mount restart listeners, and it's a very valid question because I haven't even mentioned it. 1 second, I'll show you what they look like. Oh, actually it's not here, it's here. Watch. Right, so what you saw, the restarting of those, the listening and the restarting those components fits basically here on this 20 lines of code. So mount has restart listener. You can implement it yourself. It doesn't, you know, you don't need to use it from mount. You can just say, you know, if this state changes, mount start, mount stop. I mean, it's kind of trivial to do, but it just saves you a little bit on, I guess, typing and kind of maintains everything together for yourself. But so what we did here, we created watchers. So we care whenever mission target changes or camera mode changes or store URL changes, right? We'd like to restart this state. This is how you read this. So this is a map. This is key. And this is values. This values is the brackets stands for vector, so it's like a list of things or vector of things. So this is a map of key to list, key to list, key to list. In this case, key to vector. And we say we want to create a map. Map doesn't do anything, just data, right? We create keys and what states we would like to restart on these keys. And then we just put this watcher. We just plug these watchers into mount and say listen for these keys. If you see anything happen to this key, just restart these states. That's all this guy does. This is a little more advanced than you might ever need. This is just something that's there. Since you asked, I'm just showing you this. So and we create a state which listeners, and we add watchers to this listener. Right? So this creates a listener of type of real type. I think change listener or something, or restart listener, and it basically assigns this reference to that listener. Here I'm using Envoy, which is a library I wrote for console, which can watch watch console and watch the changes on those keys. So when I change things in console, it's sort of like a blocking HTTP query. It's going to block until the keys change. When it changes, it kind of releases the lock, and I know that the keys change. And I just pass, on change, I just pass all the keys that are changed to that listener. So this is again, this hash that you asked before. In this case, hash and parenthesis means function. So this is an anonymous function. And this is the first argument. So yeah, I know it's a little, if you never did Clojure, it might seem a little cryptic, but this is almost all there is of crypticism in Clojure. So this is just an anonymous function, and I say watch path, whatever path I want to watch, which is a root path, Hubble in this case. And for every key change, just pass those keys to listeners. And those listeners say, oh, does this key change? Do I have this in this map? Yes. Then I restart these two states. So this is basically how things are tied together. And I create a state, console watcher state, where I started. And you can see how I just call this function. It creates this watcher, right? And then it returns. And then later, when I call mount start, it actually stops the watcher. And in this case, because it's a macro, I can actually refer to the var by its name, right? So I just created it, but I already can refer to it within itself. Kind of takes a couple of minutes to get your head around it, but this is just because it's a macro, you can do that. Magic. And envoy. I can probably close console. Envoy. All right, so yeah, so envoy again, it's just a small library, and there are watchers here, watch nested keys, I think, and that's exactly what we're doing. So this is kind of a simplistic version of what we're doing with console itself. We say, hey, watch this path, which is Hubble, which means the root of all the keys that I care about, and on every key change, again, anonymous function, on every key change, this print watcher says blah, right? So it just waits for it. You change the key, it says, oh, watcher says blah. You change the key, oh, watcher says blah. So that's the idea. That's the relation between in this case, between mount and console. It didn't have to be. I could go into Repple and do it manually, but I think console gives it more of a kind of navigated level of restarting parts of your system. Did it make sense? Cool.
Actually, I had one more question.
Of course.
Internet, and one book I've read mentioned a library called Component. Are you familiar?
Yeah, of course.
It's similar. It's similar to Mount? Are they solving similar problems, or is this one?
They definitely aim to solve this similar problem, and I did work with Component before I wrote Mount, and I can. I don't know if you have access to this group, or maybe on Meetup. I'll send a link. There's actually a link where I justify the need for Mount, even though Component is there. Mount component, of course. Yeah. So I have differences from component, and there's a kind of a lengthy description of why and what the differences are and why.
Okay.
I think.
You're gonna attach a link to that Meetup notes you said?
Yeah, I'll just send it to Meetup. Yeah, I'll send it to Meetup if that works, right? Okay, and. In general, component requires full lab buy-in, right? So you cannot, for example, restart parts of an application because you create those components, and components you can access state from components only. So even if you have a function that works in a database, that function somehow would be related to a component because component nests that state, right? So this is kind of the biggest philosophical difference between Mount and Component. So Component, in my mind, is a framework, whereas Mount is a library. You can retrofit application, introducing it or removing it. With Component, it's either all or nothing. And you create more of you create Clojure records, which have data and behavior, which in my mind couples both, which kind of complex it a little bit. But again, this is not to say that Component is not popular. Component is very popular. A lot of people use it. Yes, I'll definitely send a link. You can read about it. So ClojureScript, again, this is a Clojure code. compiled into JavaScript. So basically the way you work with the web application in Clojure, you write code and you reuse most of it, whether it's front end or back end. It just so happened that ClojureScript allows you to, it uses Google Clojure compiler with an S, Clojure, which optimizes, minifies, does a lot of cool things with different compilation options. You don't have to, if you don't have to optimize it if you don't want to. You can have it readable if you're in development. You can have it squeezed and obfuscated if you're not. But basically, it uses Google Clojure compiler to take the Clojure code, run it, create JavaScript, run it through the Google Clojure compiler, and create this, nice and beautiful, unreadable JavaScript things, or readable. It depends how you want it. So mount also. So I first created mount for Clojure, and then I started to receive questions whether I can work with mount in ClojureScript, because I actually didn't need to manage state in ClojureScript before, but a lot of people apparently did. And I'm not a strong front-end developer myself. I do front-end, but it's not my forte per se. But then later on, I figured that yes, it's useful there as well. So I kind of wrote it for in Clojure. You have this mode. It's called CLJ. CLJ stands for Clojure. If you're talking about the file will have, my file.clj. That extension would mean Clojure. So as you write Clojure, you can actually have files be CLJC, and that will allow you to, with some syntax, if def and all that kind of things, allow you to write code for both at the same time, right, and compile it for both for the same time. So I rewrote mount to be from Clojure to CLJC, so it can actually be compiled. The same source can be compiled to both platforms without any without the differences. Well, there's some differences, of course, but without different source files. The first thing is I approached it. I went to the ClojureScript channel on Clojurians, is a Slack group that we have, and this is Dave Nolan, the guy who works most of the time who currently works on ClojureScript, and basically I did something with namespaces, right? Some namespace magic before. And I couldn't get it to work in ClojureScript, and it appears that it's not possible. The reason it's not possible is because JavaScript itself does not have packages or groups. They need to be introduced, right? So, and especially when you compile your JavaScript in an advanced mode, in the most minified mode, and everything gets renamed and kind of jumps everything together. So if mount remembers, app.conf config, app.db.db or something, it's not available anymore once the JavaScript gets compiled and squished, right? So that's why mount can no longer reach to those references. So I couldn't follow that path. Yeah.
I just want to mention that the guy that answered your question has given a talk here before.
Oh yeah, I heard Jesse mention. Oh, so you do know that. So that's the guy. So he is the ClojureScript master. I mean, he mostly works on ClojureScript. So the reason it wouldn't work, it works in ClojureScript until you're ready for prod, and you compile in advance, and boom, it doesn't work, right? So of course it's not a workable model. I cannot, do anything like that. So there are great improvements in ClojureScript Bootstrap, which is ClojureScript written in ClojureScript, which can evaluate ClojureScript on its runtime. Think about it for a couple of minutes. So it's actually it's a great improvement because I can do namespace manipulation, but ClojureScript Bootstrap at that point where I found it was a bit slower, and right now it's still a bit slower. So I decided that this is probably not, since I have so many obstacles, this is probably not the route to take. So and I went and took a different route. So in Clojure you have a notion of derefing something. So for example, in Clojure you would have an atom, and let me show you an example since some of you guys don't use Clojure. Do I have Repple open? Okay, I don't have Repple open. So you can basically it's when you create a future, for example, or a promise or something, where you can what we call it deref it. Right? Or you create an atom, you can deref it. So when you create a future, when you put the @ sign, or you just say deref, it actually waits until the future completes, right? To give you that example. Or in case of atom, you can create an atom, for example, to be, say, 42. So I have this atom, right? So the type of the 42. So if I just do A, it's not going to give me the value back. So it just encloses the value inside itself. If I do at A, it gives me the value back, right? The reason it's done, the reason for this particular primitive, if you will, is this is more like an atomic enclosure. So it allows you to change what's inside using CAS semantics. CAS is compare and swap semantics. So you can actually access this value concurrently. It's going to guarantee to compare while you're changing this value. If somebody arrives, it'll compare, did it change right under your feet? If it did, I'll just reject this change, right? So it's a like computer sciencey thing. It's called CAS, compare and swap. So it kind of guarantees that semantics here. But the whole idea here is not about atoms or futures. It's just about a way to deref things, right? So I can actually do this, deref A. Right, the same thing. This is a shorthand for deref. So this is a reference to what's inside. I just deref what's inside, and I get the value. So I thought, okay, so if I can't use namespaces in Clojure, namespace magic in Clojure, maybe I can hide my state behind the same abstraction, right? So basically, what this means in Clojure, and the reason for this in Clojure and ClojureScript, this interfaces, if you will, or protocols, what they call in Clojure, are just named a little differently. So this is what I was talking about, the CLJC thing. Like when I write the CLJC file, and there's something that's different for ClojureScript when it's going to be compiled, and something that's different for Clojure, I just put this macro, this reader macro, right? And I say, if it's Clojure, when you compile, use this. If it's ClojureScript, when you compile, use this. Because in ClojureScript, it just so happened that the same protocol, the same interface is called different. It's called different, right? So don't mind this. This just say that it says that I create a type. This is my type, the derefable state. It has a name, and it's going to be derefable, which means I can always do at, right, on it. Inside, I implement the same semantics. I say, okay, if I deref it, that means just give me the value, right? So this actually works well for ClojureScript because no matter how minified and jammed the JavaScript is or becomes, I don't care about the actual name of a thing. I care about derefing that reference, and any reference that encloses the value and then gives me the value back. And that's kind of how I avoided. Oh, I thought why is it not that pretty? And it's because I'm inside this. Okay, you can. I should have made all these transitions faster, but let me do this. So you can see that this actually this is the WebSocket. So this gets compiled to JavaScript. This is one of the examples on Mount. You can see it within the code. So the only difference here, I use this @ sign. So that's the only difference. If I want to work in both Clojure and ClojureScript, I just put Mount in CLJC mode. I'll show you how to do that. And the only changes for your states to use them, you deref them. Right, and by derefing, I mean this @ sign. Right, so it's not much prettier. Okay, we already talked about it. Right, so this is how you put Mount in CLJC mode. You just say, this, and that's it. So you in both, in Clojure and ClojureScript, if you want to work in both, you'll deref it, right? And it has some nice properties because in Clojure, deref is intuitively associated with the state behind it, whether it's a future and it's an atom or it's a promise or whatever. It just means that there is some state, get me that state out of it. So it actually works nicely intuitively when you work in Clojure. Also, your system may start lazily without calling mount start. Is because when you deref stuff, what mount will do, it will say, oh, it's not started yet, let me start it. Right? So imagine you have 20 different states within your application, and it so happened that you start your web server, and somebody sent a request, and it went to this part of the application. So only those states that needed to be started will start, right? And the rest will just wait for their order. So it just it's an option. You can call mount start, everything will start, or you can say, okay, I don't need to start it right now because it takes too long to start that. So whenever later, I'll just issue a lazy start. States may also have watchers. This is an idea of atoms. So in Clojure atoms, you can actually add watchers on the language level. You can say, whenever a value changes on this atom, do this. right? This is just the language level. So this is not implemented in mount states. I was thinking about watchers because, especially on front end, when you create, you may create a thing that other states will subscribe to, and in order for those other states to subscribe to that thing, they need to know that this is created, right? So this is the, and since they're not dependent on each other in the code way, right? They're just subscribed just dynamically, right? They need to subscribe to that thing when call it a bus or call it something that when that thing is created. So again, this is just an idea at this point. And there is something introduced in Clojure. It's called direct linking. This has to do with compiling direct references into the Clojure source, right? So right now, at runtime, you have this dynamic invocation of things because Clojure is dynamically typed language, right? So you have at runtime you just dispatch dynamically on things. Do I have this? Do I have this? Like those virtual tables from C++, if you remember. So this is the way to say, okay, you dispatch many things, but this particular things I want you to hard code these references into compiler. The idea is that if you do that, then I can no longer in mount what I did. I took the var that represents the state, and when you change it or stop it or recompile the namespace, I just change the var myself, right? If var is directly linked, I cannot change the var myself because the reference is actually precompiled. So at runtime, I cannot do that. And direct linking works very well with dereffable state because in dereffable state I don't need to do that. I just keep enclosure. I just care about the enclosure. I don't care about the reference to the inside. This is more of an internal kind of thing. So if it doesn't make sense right now, that's fine, and you can always bother me later. So this is it's too fast. It's a problem with transitions. They're so unpredictable. Okay, so one of the things that Mount has on the ASCII level is visualization. So I don't have this, but I do have this. So once you have your application, you can actually there's some Mount tools. You can actually look at the graph of all the states. So you can say, and sometimes it actually gives you dependencies as well. Not sometimes, most of the time it'll give you dependencies. But sometimes the dependency, I wouldn't rely too much on this graph because it's not a graph. It's just the way compiler sees it, and there are some corner cases where this would not be right, so I wouldn't rely on this to be your dependencies. But this gives you, most of the time, it gives you, correct answer. What good is, what value it brings, it gives you the statuses of every state, right? And order if you need it. It just gives you kind of your Spring application context in XML, but not in XML, kind of like that. So it just gives you a little visual. So one of the things that, again, coming back to the single config, like the original question that you had, whether the config is single. So one of the things that people ask is whether I can, let's say I need to start two different application versions in the same REPL or same JVM. Since I have a single config, I cannot do that, right? Because that single config is single, right? I cannot change it for the different instance. So the only rational explanation, when I say why, the only rational explanation that I heard is sometimes people run tests and work in development in the same REPL, right? I prefer to run my test REPL separately, just to watch for changes and just to tell me whether test pass or not. But it's just my preference. Some people prefer, to work in the same REPL and do both. In this case, I created something that's called YORT, which is a mount-based thing. Basically, it creates a blueprint, which you see on the right, and you can create as many local systems, and then detaches from mount itself, right? It creates the application and detaches from those vars. So now it's self-contained system. You can spawn as many as you want in the same, as many as you want different system in the same JVM or same REPL. And one of the criticism was that it's impossible. So it's possible. So this is something that's used by a few people right now. So this actually, the question about component, this would do kind of similar thing that component would do, right? Component does. So now to criticism, I already touched on it a little bit. And again, since some of you guys are not using Clojure actively, that may not sound like anything, but I'll try to explain. So the idea is that mount uses namespaces and vars, and the idea was that the component, for example, or other solution use records and protocols, which is a very, very different approach, which saying that they don't want to bind anything to the var itself within the namespace. They would rather use a record that adheres to a protocol, and that they would create as many as they want with different values, and as many records as they want with different values. To which I say that mount is orthogonal to use of records or protocols. You can create the same records and protocols, and I have some examples here as well. And you just manage it with mount. So you create that state, and that becomes, you create a record and just bind it to that state. If it doesn't make sense right now, that just because you didn't follow the internals of argument between Clojure establishment and me, and that's fine. This is just one of the criticism. Another criticism is, as you mentioned, config. That state is singleton, which is okay because you shouldn't create states for everything. For example, you have a map, you have a value, you have some data. It doesn't mean that it's a state. In Clojure, usually the things work functionally, where you have sequences of data, right? The data is usually in sequences and then passed to the pipeline, and the pipeline takes a sequence of data, transforms the data to other data. So it doesn't really make sense to create a state for this piece of data, right? And if you have that in mind, if your states are just resources, that singletons is actually what they are. If you have a connection to a database, right, your connection, this particular connection to this database on this port with the schema is a singleton, right? If you need to create connection to a test schema, that's going to be another state. You need to create a connection to to Zookeeper, that's another state. So if you want to test, we just saw that you can really substitute the state for a value. So that's fine that it's a singleton, because you can in the test runtime you can substitute it with the value. So when you add a lot more context into what singleton this in this context, it actually becomes perfectly fine, because your resources are singletons. Your external resources, that car that passed by. One. Good. Is actually a single car, unless we're talking about multi-universes. If we're talking about multi-universes, that's also fine. You can use UART, and UART will do that. Okay, and we already talked about this a little bit. So multiple systems with the same REPL. And the way I prefer to do it, I use something like this. There's also line again, test refresh, but I use boot watch test. Actually, you can use boot speak watch test in a different REPL, which means I run it on a different terminal. I don't even need to look at it. If I change something in the code, test pass, it says ba-bum. Test fail, it says ba-boom. So I can actually hear, whether they pass or fail, and it's in a different REPL. I don't mix, my class paths. I don't mix namespaces. I don't spend 2 hours on something because I did something in REPL when I tested and it changed something. So I don't like to couple those things. I actually like to separate those things. But again, people preference is different, and that's fine. Okay, so this is like a Clojure mantra, and it stays with mount. You prefer values and immutability. Your states are values, right? And they're managed, right? So nothing can, if you create an immutable value, it's not going to get changed by mount. You can start it and stop it if it's a resource, but the value will be immutable. You prefer functions and locally bound state. This is an example with this that send SMS. When we locally bound with the let within the let binding, we'll locally bound function into mount, started and stopped it. You minimize code that has access to resources, and prefer balance, formal plus pragmatic. All right, this is just some adoption. There's Luminous, which is a great way to start if you never did anything Clojure and you want to create a simple app, and play with it like a web. It's gonna create a simple app. You can add and remove components that you want. It's a very nice way to start, doing just a simple web application and add and remove things. So Luminous is that library that uses. It's a very popular library. It uses mount. Mount also featured in this web development with Clojure book. You know, we have more and more people who helping me out, and I'm really grateful to them. It was mentioned in Narrator, Reddit, and so forth. We have Clojurian's channel, and somebody actually, there's a Mount spin-off. Somebody created Mount Lite, which is the guy who agreed with most of Mount, but not some of Mount, so he did his own thing, which is cool. I really like it. At the end, I just want to say that balance, and this is mostly to address the criticism that I usually get. So balance is composable. You don't need to, you don't need to follow this way or this way to reach balance. You can create different things and compose it yourself and reach your own balance. There's no ultimate truth. There's no ultimate pattern, and this is just a way to do things, and the other way is just as a way as this one, right? So thanks to all these people, and right now there's more people. This is probably was taken a couple months ago, maybe 6 months ago. Let's talk. If you have any questions, you can either submit a GitHub issue or find me on Clojurians on Mount channel, or just find me while I'm here. So thank you very much, guys. If you have any questions.